Alright, I'm just going to jump into this review. The first two problems want me to use the substitution method, and they're set up perfectly, at least number one set up perfectly for the substitution method. What I'm going to do eventually is take the x in the top equation and change it to y plus 1. I don't like working with the equations that have fractions, so before I substitute y plus 1 in for the x, I'm going to multiply and make a clean version of that top equation that doesn't have fractions. And I'm going to multiply by the least common denominator between 5 and 4, which is 20. I'm going to multiply each fraction and even the number to the right of the equal sign by 20, or I can write 20 over 1. First canceling, I'm going to cancel the 5 and the 20. The 20 is going to become a 4. I'm going to be left with 4 times x, which I'm going to write as 16x. Second canceling, I'm going to cancel the 20 and the 4 and get a 5. Fractions gone, I'm left with 5 times 1y, which I'm going to write as plus 5y. To the right of the equal sign, 20 times 5 is going to give me 100. This is what I'm going to substitute x equal to y plus 1. So I'm going to change that x to a y plus 1 and write 16 times y plus 1 plus 5y equals 100. Clear the parentheses by going 16 times y and getting 16y, 16 times 1 and getting plus 16, plus 5y equals 100. Now on the left-hand side, combine my like terms. 16y and 5y is going to be 21y. So I get 21y plus 16 equals 100 minus 16 minus 16. This gives me 21y equals to 84, and then divide by 21, and get y equal to 4. I need to solve for x, because my answer has to have both an x and a y. I'm going to use the equation x equal to y plus 1, plug 4 in for the y, and get x equal to 4 plus 1, and get x equal to 5. My answer to problem 1 should be x equal to 5, y equal to 4. I'm going to check, and I have the advantage now that this is a system of linear equations. I can check it on my calculator. If I rewrite this top equation by minusing y from both sides, if I rewrite the top equation as x minus y equal to 1, and I leave the top equation 4/5 x plus 1/4 y equal to 5, I can check this real quickly by, on my calculator, entering a 2x3 matrix and doing RREFA. So I'm going to do RREFA for my cheating checking. And when I do this, so this is all optional, but checking is never a bad idea. For systems of linear equations, they can all be checked by doing RREFA. And if the numbers in the right-hand column are 5 and 4, when I do my RREFA, I know my answer is right. So let me go ahead and check this. I took the bottom equation, set it up so that the x's and y's lined up to the top equation. I'm going to enter this on my calculator now as a matrix. So I'm going to go second matrix, edit, and then 2, enter, 3, enter, and then enter the numbers. Got them in. Second quit. Second matrix math. We did a bunch of this. Hopefully you haven't forgot. And then second matrix names, enter. I see the 5 and 4. I think my answer is right. That's a cheating, easy way to check it. You got to do it by hand on the test, but you can definitely check so you know your answer is right. If I'm doing problem 2 by the substitution method, the first thing I'm going to do is I'm going to solve the bottom for x, because that's the easy thing to do. The bottom is x minus y equal to 41. It's easy enough to solve that for x. And to do the substitution method, you have to have one of the equations solved for a letter. So I've solved the bottom for x, and now I'm going to substitute into the top. And the thing I'm going to substitute is I'm going to take this y plus 41 and change it in for that x. So I'm going to go 3 times y plus 41 minus 2y equals to 5. Clear the parentheses, going 3 times y, which is 3y, 3 times 41, which is plus 123, minus 2y equals to 5. On the left-hand side, combine the 3y and 2y and get 1y, or just y. Leave the plus 123, leave the equal to 5, and then minus 123 from both sides. This is going to give me y equals negative 118. That's a troublesome answer, to say the least. Now I need to solve for x, and I'll check here in a second. I'm going to use the equation x equals y plus 41 and plug in negative 118 for y. So get x equals negative 118 plus 41, and negative 118 plus 41 equals to negative 77. I claim my x is negative 77. My y is negative 118. I hope that's my answer. The easiest way to check it, this is a system of linear equations. Systems of linear equations can be checked by matrices. And this one's set up perfectly for my RREF. So I'm going to enter the matrix that has 3 and 1 in the x column, negative 2 and negative 1 in the y column, 5 and 41 in the z column, and the equals column. I'm going to do RREF A, and it better give me 1, 0, negative 77, 0, 1, negative 118. If it doesn't give me exactly this matrix, then those answers aren't right, because the x and the y's need to be in the far right-hand column. So best I can, let's enter this matrix. So clear out this screen, second and quit. Let's have a gnat floating around here. Second matrix, edit, 2, enter, 3, enter, 3, negative 2, 5, 1, negative 1, 41. Looks correct. Second quit, second matrix math, RREF, second matrix names. And I see those numbers, so I'm perfectly content with that answer, even though it was a surprising answer for me. All right, on to number 3 and 4, which want me to use the elimination method. For the elimination method, you need to get the same number with different signs in front of the letters. What I'm going to do in this problem is I'm going to make the top have a positive 12y and the bottom have a negative 12y, so the y's will cancel. To get the top to have a positive 12y, I need to multiply everything in the top equation by 4. I go 4 times 2x is 8x, 4 times 3y is plus 12y, 4 times 3, 13 I think is 52. In the bottom, I'm going to multiply everything by 3. I'm going to go 3 times 5x is 15x, 3 times minus 4y is minus 12y, 3 times 21 is 63. Combine these together, 8x and 15x is 23x. 52 and 63 is 115. Divide both sides by 23. I'll get x equal to, I think that's 5. And it is. Done with half of it, now I need to solve for y. I need to pick any equation that has a y. I like that one, so I'm going to use the equation 2x plus 3y equal to 13. The reason I don't like that one is because the y has negatives. The reason I don't like these is because the numbers are bigger. I'm going to plug in 5 for x and solve for y, so I'll get 2 times 5 plus 3y equals to 13. That's going to give me 10 plus 3y equals to 13. I'll minus 10 from both sides, which will lead me to 3y equal to 3, and then divide by 3, divide by 3. I'll get y equal to 1. ready to write my answer, and I'm also ready to check my answer. My answer is going to be x equal to 5, y equal to 1. I'm going to enter a 2 by 3 matrix and do RREFA and make sure that when I start with the matrix 2, 3, 13, 5, negative 4, 21, make sure that when I do RREFA that I get 1, 0, 5, 0, 1, 1, because the numbers in the right-hand column are the answers for x's and y's. So real quickly, I'll just rock this on my calculator. So second matrix, edit. It's a 2 by 3 matrix. Just peek out the numbers, they look okay. Second quit, second matrix, math, RREF, second matrix, names, enter. Feel good about that. My answer must be right because my by hand and my calculator work match just perfectly. 4 worries me. Let me get the answer first by entering the matrix 4/9, 2/3, 12, 1, negative 1, and 12 on my calculator. And RREF in it. So second matrix, edit. It's a 2 by 3 matrix. 4 divided by 9, 2 divided by 3, 12, 1, negative 1, and 12. Yick. Second quit. Second matrix math, RREF. Second matrix names, enter. I get 1, 0, 18, 0, 1, and 6. I believe the answer is going to be x equal to 18, y equal to 6. If you write an answer down without any work on the test, you're going to lose every single point. I need to see a bit of work. I don't like that top equation. Let me clean up that top equation before I get going. So I'm going to clear the fractions in the top equation before I do anything. And I'm going to clear the fractions by multiplying through by 9, which is the least common denominator between 9 and 3. So I'm going to go 9 over 1 times the 4/9 x plus 9 over 1 times 2/3 y, and then do 9 times 12. I don't need to do the 9 over 1 there because it's not a fraction. Now I'm going to cancel. First canceling, the 9s are going to cancel. I'm just going to be left with a 4 times x. Second canceling, the 9 and the 3 are going to cancel, but the 9's not going to go away. It's going to turn into a 3. It's going to leave me with 3 times 2y, which is a 6y. To the right of the equal sign, 9 times 12 is 108. So I'm not going to use the top equation that was given to me because it's not pleasant. The bottom equation I'm going to leave at x minus y equals to 12. And now I'm going to eliminate the y's. I'm going to leave the top with a positive 6y, and I'm going to make the bottom have a negative 6y by multiplying it by 6. So top is going to stay 4x plus 6y equals 108. Bottom, 6 times x is 6x. 6 times minus 1y is minus 6y. 6 times 12 is 72. Add these together. 4x plus 6x is 10x. Y's cancel. 108 plus 72 is 180. Divide by 10. Divide by 10. And I get x equal to 18, which is good. Now I need to solve for y. I can pick any equation that has a y. And I'm really torn. I like this equation because the numbers are small, but the y is negative. I like that equation because the y is positive, but the numbers are big. I'm going to default to the small numbers. So I'm going to use this x minus 1y equal to 12. I'm going to plug 18 in for x and get 18 minus 1y equal to 12. I'm going to minus 18 from both sides and get minus 1y equals to minus 6. And then I'm going to divide both sides by negative 1. and get y equal to 6, just like I knew was going to happen. So the answers really aren't where you're going to be getting your points for these first few problems on the test, because you're should know the answer either ahead of time or pretty quickly into the work. So I don't grade the answer, I grade the work for the first few problems. 5 and 6, I wish I only had one of these. There are 3 equations and 3 unknowns, and they want me to solve by hand. And I'll do that, but let me get my answer first for number 5. For number 5, I'm going to do my answer on my calculator by entering a 3 by 4 matrix, pulling off the coefficients from the letters, and taking the numbers to the right of the equal sign. I'm going to do RREFA. And my calculator is going to present me with the answers to the right of the equal sign. So real quickly, I'm going to enter that matrix. So on second matrix, edit, that's a 3 by 4 matrix. Double check to make sure I entered it right. So 2, 4, negative 5, negative 5, negative 1, 1, 2, 5, 1, negative 3, 3, and 4. Entered it right. So now second matrix, math, RREF, second matrix, names, enter, enter, math, enter, enter. Really unhappy with this. My answers are going to be x equal to 11 over 14, y equal to 17 over 14, z equal to 16 over 7. That's really, really unfortunate, but I believe that's the right answer, specifically because I double-checked the matrix on my calculator and it looked right. I don't usually make fraction answers, but they can happen. Let me double-check to make sure I entered this matrix right. So 2, 4, negative 5, negative 5, negative 1, 1, 2, 5, 1, negative 3, 3, and 4. So I actually did enter it right, which means I've got to push through the math now to figure out the answer. So let me do it. I should probably do it all on another sheet of paper, but I'll gamble. It's probably going to flow down to another sheet though. Step 1, pair the middle equation with the other two. Middle equation is negative x plus y plus 2z equals to 5. I'm going to pair it with the top equation, 2x plus 4y minus 5z equals negative 5. And pair that middle equation, negative x plus y plus 2z equals to 5, with the bottom equation, x minus 3y plus 3z equal to 4. The reason I give you the hints as much as anything is to make my grading easier. To drop out the x's from the first set, I'm going to multiply by 2. I'm going to go 2 times minus x and get minus 2x. 2 times positive y and get positive 2y. 2 times 2z and get 4z. And then 2 times 5 and get 10. I'm going to leave the bottom row, 2x plus 4y minus 5z equals to negative 5. Add these together. X's cancel. 2y plus 4y is 6y. 4z minus 5z is minus 1z. 10 minus 5 is positive 5. Next pair, I can just add together to drop the x's out because the x's are ready to go. So x's cancel. 1y minus 3y is minus 2y. 2z plus 3z is positive 5z. 5 plus 4 is equal to 9. Done with step 1. Step 2 involves taking these answers that I just came up with, stacking them on top of each other, and doing the elimination method. I'll get 2 of the 3 letters for my answer. So I'm going to, for my step 2, take the 6y minus 1z equals to 5, stack it on top to the minus 2y plus 5z equals to 9, and I should get 17 over 14 for y, 16 over 7 for z. Let me push it to get there. I'm going to do the elimination method for my third time. I'm going to drop out the y's. The top I'm going to leave 6y minus 1z equals to 5. The bottom I'm going to make minus 6y plus 15z equals to 27. When I add these, the y's cancel. The z's have opposite signs, so I'm going to get a 14z. The numbers have the same signs. I add and get 32. I'm going to divide by 14, divide by 14. On the left side, the 14's cancel. On the right side, I divide the numbers by 2. 32 divided by 2 is 16. 14 divided by 2 is 7. I need to solve for y using that horrible z, which means I'm going to break out my calculator. I'm going to use this equation that has a nice positive y and solve for z. So I'm going to solve for y. I'm going to go 6y minus z, which is 16 over 7. I don't need the 1 in front of it, equals to 5. I'm going to add 16 over 7 to both sides, and I don't like to do fraction work by hand, especially on the videos, because I make too many mistakes. So I'm going to leave the left side with just a 6y. I'm canceling the 16 over 7s. On the right side, I'm going 5 plus 16 divided by 7. Math, enter, enter, and I get 51 over 7. Now I'm going to divide both sides by 6. On the left side, I get my y. On the right side, I'm going to go 51, put it in a parentheses maybe, 51 divided by 7, and then divided by 6, and then math, enter, enter. I get y equal to 17 over 14. This is good. I have z is 16 over 7, y is 17 over 14. The last thing I need to do is solve for x. I can pick any equation with an x to solve for x. I'm going to pick that equation because it has a nice x in it. So I'm going to use, when I go to solve for x, I'm going to use x minus 3y plus 3z equals to 4, and then the two answers that I just came up with. So I'm going to go x minus 3 times 17 over 14 plus 3 times 16 over 7 equals to 4. Let me find out what minus 3 times 17 over 14 is. It's minus 51 over 14. Let's find out what 3 times 16 over 7 is. It's 48 over 7. Now I'm going to combine these, minus 51 over 14 plus 48 over 7. And get plus 45 over 14. So I get x plus 45 over 14 equals to 4. And now I'm just going to minus 45 over 14 and minus 45 over 14. On the left side, I'm going to have my x. On my right side, I'm just going to do 4 minus 45 divided by 14. Math, enter, enter, and I get 11 over 14. So my answer is going to be x is 11 over 14. Y is 17 over 14. Z is 16 over 7. And that matches up perfectly what I got on my calculator, so I know my work is perfect. So that's what I'm looking for on the test. A correct answer without any work, you're going to lose every single point that's available. 6 is another unpleasant problem, so let me give it a go. Again, I'm going to get an answer on my calculator. I'm going to enter a 3x4 matrix just because I know I can get the answer super fast and way more accurate than I can do by hand, at least with that amount of speed. I'm going to do an RREF, and the numbers in the right-hand column are going to be my answers. So let me just enter this real quickly. So second matrix, edit this. It's a 3x4 matrix. Type in the coefficients. Go back to the main screen, make sure I entered it right. So, 2 2, 1, negative 5, 3, negative 3, 2, 5, 0, 1, negative 1, and 4. Feels good about that. Now second matrix math, RREF, second matrix enter, enter, math enter, enter. 81 over 17, 44 over 17, 31 over 17. The answer, another fraction. On the test, this won't be a fraction, but if you can do the fractions, you can do the non-fractions, that's for certain. So 81 over 17 is the x. 44 over 17 is the y. Not that it's that readable there, but hopefully it's readable there. And 31 over 17 is the z. Let me push through this and see what happens. So first up, pair the bottom with the other two and drop out the y's. So I'm going to take the bottom equation, x minus y plus z equals to 4. Pair it with the top equation of 2x plus y minus 5z equals to 3. Pair the bottom equation, x minus y plus z equals to 4, with the middle equation, minus 3x plus 2y plus 5z equals to 0. And I want to drop out the y's. In this first pairing, the y's are going to cancel perfectly. So I'm just going to add them together. I'm going to add 1x plus 2x and get 3x. 1z minus 5z and get minus 4z. And 4 plus 3 and get 7. In the second pair, I'm going to multiply the top by 2 to make the top have a negative 2y to cancel with the other 2y. So I'm going to go 2 times x is 2x. 2 times minus y is minus 2y. 2 times z is plus 2z, 2 times 4 is 8, and then minus 3x plus 2y plus 5z equals to 0. Add these together and get negative 1x, y's cancel, plus 7z equals to 8. Ready to move on to step 2, where I'm going to go onto a separate sheet of paper and write these two equations on top of each other. 3x minus 4z equals to 7, negative 1x plus 7z equals to 8. I should get the 81 over 17 for x and 31 over 17 for y when I work with this pair of equations. I'm going to start solving this by dropping out the x's. I'm going to multiply the bottom by 3 and leave the top alone, which is going to give me 3x minus 4z equals to 7. And negative 3x plus 21z equals to 24. Add these together. X's cancel. Z's have opposite signs. I subtract and get a 17z. 7 and 24 add to be 31. Divide by 17. Divide by 17. And I get z equals 31 over 17. Now I'm going to solve for x. And I'm going to use this equation because the x's are positive. That equation might not be that bad either because there's a 1 in front of the x. But I prefer positives to negatives. So I'm going to use 3x minus 4z equals to 7. And in for the z, I'm going to plug in 31 over 17. When I get to these calculator problems, or fraction problems, I break out my calculator. First multiplication I need to do is negative 4 times 31 divided by 17, and math, enter, enter. This is going to give me 3x minus 124 over 17 equals to 7. Now I'm going to add 124 over 17 to both sides. I certainly don't want to do these fractions by hand. On the left side, fraction cancels. I'm left with the 3x. On the right side, I need to do 7 plus 124 divided by 17. And I get 243 over 17. Now I'm going to divide both sides by 3. On the left side, I'm going to get an x. On the right side, I'm going to do 243 divided by 17 in a parentheses, divided by 3. Math, enter, enter, and get x equals to 81 over 17. This is good. I see z equal to 31 over 17, x equal to 81 over 17, matches up my answer perfectly. Done with the second step. Now I need to solve for y. I can pick any equation that has a y. I like that equation because the y is really nice. So when I go to solve for y, even though I have my choice of any equation, I'm going to take that one because it has the nicest y. So I'm going to use 2x plus y minus 5z equal to 3. I'm going to use that equation. And in for z, and for x, I'm going to plug 81 over 17. So I'm going to get 2 times 81 over 17. I'm going to leave the y alone. And then for z, I'm going to plug in 31 over 17. And then equals to 3. And do these fraction multiplications on my calculator, unless you can do it. They're not hard to do in your head, but I just don't feel good about that when I'm doing the videos. So this one comes out to 162 over 17 plus y minus, and then 5 times 31 over 17 gives me 155 over 17. Let me subtract these two. Pretty sure you get 7 over 17, but I'm not going to take that risk. I'm going to go 162 divided by 17 minus 155 divided by 17. Math, enter, enter. I do get 7 over 17. So now I have y plus 7 over 17 equals to 3. And I'm going to minus 7 over 17 minus 7 over 17. It looks like I did divide. It's supposed to be minus. On the left-hand side, when I do that minus, I get my y. On the right-hand side, I go 3 minus 7 divided by 17. Math, enter, enter, and I get y equals to 44 over 17, which is good because when I did the problem earlier, I had 44 over 17 for the y. So I can just write my answer again on this sheet, even though I've already written my answer on the other sheet. The answer is x equals 81 over 17, y equals to 44 over 17, and z equals to 31 over 17. Oh, right. Yuck. The next few problems want me to solve using matrices, and a few of them have been deleted. And, well, a few of them haven't been deleted, but they should be deleted. 7 and 8 I'm going to do by hand. There are 2 equations and 2 unknowns, and I want to do them by matrices by hand. 9 and 10 I'm going to just tell you to skip. There are 3 equations and 3 unknowns. We won't do those with matrices. So for problem 7, my first matrix, if I want to do this by hand, at some point I'm going to check on my calculator. I'm going to do it all by my hand and then check on my calculator. My first matrix is going to be 1, 2, and 10, 2, negative 3, and negative 1. And then I'm going to drop out the x. I'm going to leave the top row the same. And make a new bottom row. So as I go to do these, I'm going to get a first matrix, a second matrix, and the third matrix will be the answer matrix. My second matrix for this problem, the top row is going to be 1, 2, and 10. The top row doesn't change on the first step. So now I'm going to try to drop the x's out. To drop the x's out, I'm going to multiply the top row by negative 2. I'm going to make it negative 2, negative 4, and then negative 2 times 10 is negative 20, and leave the bottom row 2, negative 3, negative 1. Add these together, opposite signs subtract. Negative 4 and negative 3 is negative 7. Negative 20 and negative 1 is negative 21. Because all those numbers are divisible by negative 7, I'm going to divide by negative 7. And get 0, 1, and 3 for my bottom row. So on the first step, I'm dropping out the x's and making a new bottom row. Done with the first step, on to the second step. The second step, I'm going to drop out the y. Leave the bottom row the same. Make a new top row. And if I do this right, when I pull out my calculator for my third and final matrix, it's going to match up. So my last matrix, or my third matrix, the bottom row is going to stay the same. The bottom row is 0, 1, and 3. I'm going to leave it the same. And for the top row, I'm going to eliminate the y's. I'm going to multiply this bottom one by -2. I'm going to leave the top one 1, 2, and 10. And for the bottom, I'll go -2 times 0 is 0. -2 times 1 is -2. -2 times -3 is -2 times 3 is -6. Combine and get 1, 0, and 4 for my new top row. The numbers in the right-hand column are my answers. So the answer should be x equal to 4, y equal to 3. When I do this on my calculator, I'm going to enter this first matrix, do RREFA, and it better give me that matrix. If it doesn't, I've made a mistake. So let me enter this on my calculator real quickly as a 2 by 3 matrix. So in matrix A, I'm going to enter a 2 by 3 matrix. Enter this 1, 2, 10, 2, -3, -1. Double check that I've entered it right. So 1, 2, 10, 2, -3, -1. It's in right. So now second matrix, math, RREF, second matrix, names, parentheses, and I get exactly that matrix, so I know my work is perfect and my answer is correct. Absolutely on the test for this problem that says solve the system of equations using matrices and row operations, I 100% need to see all the work. If I don't see the elimination method done twice and you have the right answer, you lose all the points. Do the same thing for problem 8. I'll do it by hand and then I'll do it on my calculator. So the first matrix, and again, I would never solve these using matrices unless I was specifically told to use matrices, in which we are here. So the first matrix is going to be 3, -2, 11, 1, -7, -10. First step, eliminate the x, leave top the same, make a new bottom. So for my second matrix, the top row is going to remain 3, -2, and 11. To eliminate the x's, I'm going to multiply the bottom by -3, so the x's will go. The top I'm going to leave at 3, -2, and 11. Then for the bottom, -3 times 1 is -3. -3 times -7 is 21. -3 times -10 is 30. Add these together, I get 0, 19, and 41. Really, I'm worried about this a little bit, so let me make sure I haven't messed up. 3, -2, 11. 1, -7, -10. -3 times 1 is -3. -3 times -7 is 21. -3 times -10 is 30. I think 19 divided by 41 doesn't work so well. If I do 41 divided by 19, I get 41 over 19. So my second matrix, I'm not going to introduce a fraction. I'm going to write 0, 19, and 41. Done with the first step. Now I need to eliminate the y's. I'm going to leave the bottom the same and make a new top. I'm going to get at least one fraction answer, maybe both fractions. So I need to eliminate the y, and I'm going to multiply the top by 19, the bottom by 2. That's going to give me 38, which will cancel out these horrible numbers that I need to cancel out. So I'm going to go top 19 times 3. Wish this wasn't such a fight to get this to work. So top 19 times 3, it's going to give me 57. And then 19 times -2 and get -38. And then 19 times 11 and get 209. Bottom, 2 times 0 is 0. 2 times 19 is 38. And 2 times 41 is 82. Combine. 57 plus 0 is 57. The 38s cancel. And 209 plus 82 is 291. I can go ahead and divide this and see what happens. So I'm going to divide by 57, divide by 57, divide by 57. 57 divided by 57 is 1. 0 divided by 57 is 0. And 291 divided by 57 is 97 over 19. That's going to be my top row now. So my top row is going to be 1, 0, 97 over 19. I'm supposed to leave the bottom row the same at 0, 19, and 41. So this is my third matrix. When we get a fraction answer, we pick up an extra step. That extra step is to now divide out that bottom row. That bottom row, which I haven't taken the time to divide yet, I'm going to divide everything by 19. And that's going to take me to my final matrix. My final matrix is going to have 1, 0, 97 over 19, and then 0 divided by 19 is 0, 19 divided by 19 is 1, 41 over 19 doesn't reduce, and get 41 over 19. The answer is supposed to be x equals 97 over 19, y equals 41 over 19. Let me double check by entering this matrix in my calculator and doing the RREF for it. So second matrix, edit, that's a 2 by 3 matrix. 3 enter, negative 2 enter, 11 enter, 1 enter, negative 7 enter, negative 10 enter. Looks like it's entered right. Second matrix, math, RREF, second matrix, names, and then math, enter, enter, and I see 97 over 19 and 41 over 19. So that's just an unfortunate correct answer, but it's correct. The next two problems, I promise you I won't put on the test. I don't want to put another hour into this video doing these. These want me to do 3 equations and 3 unknowns using matrices, and that won't be on the test, so don't worry about those. I should have deleted those from the video, from the section, but I didn't. So just go ahead and skip those. 11 and 12 want us to do using Cramer's rule, and Cramer's rule is easy. In Cramer's rule, we need to get 3 matrices, and then we're going to find the determinant of. The first matrix D has the coefficients from the x column. The coefficients from the x's are 4 and 2, and then the coefficients from the y's, which are negative 2 and 5. To find the determinant for matrix D by hand, I'm going to cross multiply down and go 4 times 5, and then cross multiply up and go 2 times negative 2, and I'm going to subtract those results. D is going to be 20 minus a negative 4, which is going to be 24. So I have the x column first and the y column second in the D matrix. The D sub x matrix has the numbers from the equal column first, which are the 5 and 2, and then the numbers from the y column, which are negative 2 and 5. To figure out what D sub x is, I cross multiply down and go 5 times 5. I cross multiply up and go 2 times negative 2. Subtract those. This is going to be 25 minus a negative 4. D sub x is going to be 29. Yuck. Then I create a D sub y number. D sub y has the numbers from the x column first, which are 4 and 2. Then the numbers from the equal column, which are 5 and 2. Let me cross multiply down and go 4 times 2, which is 8. Cross multiply up and do 2 times 5, which is 10, and subtract those results. I get 8 minus 10 is negative 2. So D sub y is negative 2. So on the test, you're going to be asked to label all of these. So you're going to be asked what D is. You're going to be asked what D sub x is. You're going to be asked what D sub y is. And then you're going to be asked what the answer is. I know that x is equal to D sub x over D. So it's going to be 29 over 24. And I know that y equals the d sub y over d, which is going to equal to negative 2 over 24, which reduces to negative 1/12. The answer to problem 11 is x equal to 29 over 24 and y equals to negative 1 over 12. Let me double check to make sure that's right, because I don't like fraction answers. I'm getting too many of them. I'm going to make a matrix for this. The matrix I'm going to enter is 4, negative 2, 5, and then 2, 5, and 2. And then second matrix, math, RREF. Second matrix, names A, math, enter, enter. I see 29 over 24 and negative 1/12, so I know my answer is correct. So you're going to need to show on the test more than just doing RREFA. When you're asked to do Cramer's rule, you're going to calculate one more determinant than there is letters to solve for. Here there were 2 letters to solve for, so I calculated 3 determinants. And then once I got those 3 determinants, I divide to get the values of x and y, or x, y, and z if I need an x, y, and z. The next problem wants me to use Cramer's rule to get an answer for an x, y, and a z. And this is going to require more determinants than I care to do. And they're big determinants, and I'm going to use my calculator to figure out what the determinant is. The first determinant I'm going to need is d, and that's just entering the numbers from the x column, the y column, and the z column. The numbers from the x column are 1, 3, and 4. The numbers from the y column are 2, 5, and negative 2. The numbers from the z column are negative 1, negative 4, and 1. I'm going to find out what d equals by calculating the determinant of this matrix, and I don't want to do that by hand. So on my calculator, I'm going to put this in matrix. I'll just put it in matrix A. So I'm going to go second matrix. This is a 3 by 3 matrix, and I'm just going to enter all the numbers that I can see there. So 1, 2, negative 1, 3, 5, negative 4, 4, negative 2, and 1. So I just took this matrix that I created with the x's, the y's, and the z coefficients. 1, 2, negative 1, 3, 5, negative 4, 4, negative 2, 1. I hit second and quit. Now second matrix, arrow over to math. Hit enter on DET and do the determinant of that matrix A. So now second matrix, names A, parentheses, and D is going to be the number negative 15. I don't want to do that by hand. It's just way too much work to do by hand. The next determinant I'm going to need to compute is called D sub x. It has the numbers from the equals column first. The numbers from the equals column are 6, 13, and 19. Then it has the coefficients of the y's, which are 2, 5, and negative 2. Then it has the coefficients of the z's, which are negative 1, negative 4, and 1. I'm going to enter this and find its determinant real quickly on my calculator. It's another 3 by 3 matrix. I'm just going to put it right in matrix A again. So in matrix A, I'm going to enter a 3 by 3 matrix. If you're slick, you don't need to type the whole thing in. If you're not slick, you can just type the whole thing in like I'm doing. Make sure I have it right. So 6, 2, negative 1, 13, 5, negative 4, 19, negative 2, and 1. It looks like it's in right. So second quit, second matrix math, determinant, second matrix names, parentheses, d sub x equals to negative 75. Now I'm going to find a d sub y. D sub y is going to have numbers from the x column first, which are 1, 3, and 4. Then the numbers from the equals column, which are 6, 13, and 19. And then the numbers from the z column, which are negative 1, negative 4, and 1. I'm going to enter that as a 3 by 3 matrix and use my calculator to find out what d sub y is. So real quickly now I'm going to enter that matrix as a 3 by 3 matrix. 1, 6, negative 1, 3, 13, negative 4, 4, 19, and 1. 1, 6, negative 1, 3, 13, negative 4, 4, 19, and 1. Quit out of there. So second matrix math, DET, second matrix, enter, enter, D sub y is negative 30. Last one I need to compute is D sub z. And D sub z starts off with the coefficients of the x's, which are 1, 3, and 4. Then it has the coefficients of the y's, which are 2, 5, and negative 2. And then it has the coefficients of the equals column, which is 6, 13, and 19. For each letter, we change its column to the equal column. I'm going to enter this on my calculator. Second matrix, edit. It's a 3 by 3 matrix. 1, 2, 6, 3, 5, 13, 4, negative 2, 19. Second quit. Second matrix math, DET, second matrix names, parentheses, D sub z equals to negative 45. So I have the 4 determinants computed that I need to compute. Each one of these on the test is probably worth 2 points each. Now I need to get my answer, and I can get my answer just right in here. I'm going to do the work in an opposite color. X is going to be D sub x over D. D sub x is negative 75. D is negative 15. You can divide those on your calculator. Those come out to be 5. Y is D sub y divided by D. D sub y is negative 30. D is negative 15. Negative 30 divided by negative 15 is 2. And Z equals D sub z over D. D sub z is negative 45. D is negative 15. Divide those on your calculator if you can't do them in your head, and you get 3. So the answer is x equal to 5, y equal to 2, z equal to 3. So my answer is x equal to 5, y equal to 2, z equal to 3. Let me enter a matrix and do RREFA to make sure I haven't made a mistake. So the matrix I'm going to enter is going to go second matrix, edit. It's going to be a 3 by 4 matrix. 1, 2, negative 1, 6, 3, 5, negative 4, 13, 4, negative 2, 1, and 19. Second quit, second matrix math, RREF, second matrix names. I see 5, 2, and 3 right down that column, so I know my answer is right. On the test, you're going to have to do all the determinants when you're asked to solve a problem using Cramer's rule. So it's probably a reasonable place to stop. We have a handful of problems left, but the video's getting kind of long, so I'll make a part 2.